In 1939, the Pennsylvania Railroad unveiled what was supposed to reshape American rail forever. 140 feet of streamlined steel, the largest steam locomotive ever constructed. It could hit 100 miles per hour, and yet it was effectively locked out of the very network it was built to dominate.
The S1 didn't fail because it lacked power. It failed because nothing around it could match its scale. March 13, 1939. The gates of the New York World's Fair opened, and standing there, glowing beneath the pavilion lights, was the Pennsylvania Railroad S1. Over 140 feet long, longer than a blue whale, longer than most city blocks. It stretched across the exhibition floor like something pulled from a distant century. Raymond Loewy's streamlined body, all sweeping chrome and aggressive curves, seized the crowd instantly. This wasn't just a locomotive, it was a declaration of American ambition, a statement that speed and design could collapse any distance.
Throughout the fair, the S1 put on its own performance. Elevated on rollers, its 7-foot driving wheels turned at a steady 60 miles per hour, driven by its own steam. Crowds watched the rods blur and the pistons stroke, the machine accumulating nearly 50,000 simulated miles without moving 1 inch down the track.
Children fogged the glass with their breath. Engineers filled notebooks. Reporters wired back stories about the birth of a new era. The S1 was lettered not just for the Pennsylvania Railroad, but for American railroads broadly. A symbol of national identity, a technological statement meant to leave everything before it in the dust. In those months, the S1 was more than a machine. It was ambition forged in steel, a spectacle that challenged the world to reimagine what rail travel could become. But beyond the fairgrounds, the real examination waited on tracks built for an entirely different future. Altoona Works and Baldwin Locomotive Works came together to build something without precedent. The S1 measured 140 feet 2.5 inches from coupler to coupler, longer than some bridges, nearly double the length of the largest locomotives then running. Its wheel arrangement, a 6-4-4-6, was one of a kind. 6 leading wheels, 2 sets of 4 driving wheels each, 7 feet across, and 6 trailing wheels, all locked inside a single rigid frame. Those 7-foot driving wheels were the largest ever fitted to any locomotive. Beneath the streamlined shell, the S1 was pure engineering audacity. The boiler ran nearly the full length of the engine, feeding massive cylinders on either side. Inside the cab, engineers faced an instrument panel worthy of a naval vessel. Every element was oriented towards speed, stable through 100 miles per hour, capable of hauling 1,000-ton trains without strain. The final cost came to $669,780, a figure that could have funded an entire fleet of conventional engines. But the S1 was never intended to be conventional. It was built to be what came next. A machine so far ahead, it seemed to have no ceiling except the rails themselves. And yet, buried within all that size and power was a fundamental contradiction, a rigid, unforgiving frame that would eventually consume everything it had promised. The S1's greatest strength was also its breaking point. At 77 feet 9.5 inches from pilot to trailing truck, its rigid frame was longer than most houses. Where articulated locomotives could flex and negotiate curves, the S1 moved as one unyielding steel beam. On straight track, that rigidity delivered high-speed stability, but American rail lines aren't straight forever. They bend and tighten, particularly around stations and yards. The S1's frame allowed just 2¼ inches of lateral movement, barely wider than a thumb. That margin was meant to help the wheels shift slightly through curves. It was nowhere near sufficient for the tight geometry of most routes. Nearly half the locomotive's weight, 47%, bore down through its driving wheels, with the remainder distributed across its large 6-wheel trucks. On paper, this looked like stability. In practice, it reduced the grip holding those drivers to the rail. On diagrams, the S1 looked like the future. On actual track, its dimensions became a liability. The rigid wheelbase resisted every curve, pulling against the rail with each degree of bend. lateral motion devices couldn't compensate. Every turn introduced derailment risk or accelerated wear, and the engine's real capability could only be unlocked on the rare stretches of perfectly level, perfectly straight mainline. The S1 was engineered for speed. It simply could not accommodate the world it was meant to lead. On the open corridor between Chicago and Crestline, the S1 finally had space to prove itself. Boiler roaring, throttle fully open, it ripped down the track at a verified 100.97 miles per hour, a figure that briefly placed it among the great machines of its era. The 7-foot driver spun into invisibility, the enormous pistons generating more than 76,000 pounds of tractive effort. This wasn't speed as a spectacle. The S1 could move a train weighing 1,350 tons, a performance that outclassed the standard workhorses of the period. But every mile came at a severe cost. Each run burned through 48,000 pounds of coal and consumed 36,000 gallons of water, enough to fill a backyard pool, empty it, and fill it again every single trip. The S1 didn't just use fuel, it devoured resources at a rate nothing else could match. Every high-speed run meant more stress, more maintenance, more expenditure. The numbers made the problem plain. For all its capability, the S1 was an operating liability, a machine that could outrun almost anything except its own consumption. The S1's operational world shrank to a single corridor. Chicago to Crestline, Ohio, 283 miles of near perfectly straight track became its permanent boundary. Nowhere else on the Pennsylvania Railroad could the locomotive operate. Its rigid frame, too long for most curves, excluded it from the winding routes threading through the rest of the system. Turntables, the rotating platforms used to reverse engines, were too short to accommodate its full length. Yard tracks and station approaches, designed for smaller, more flexible machines, forced the S1 to slow to a crawl or reroute entirely. There was no workaround. The S1 was imprisoned by its own dimensions. For 6 years, the locomotive ran back and forth between Chicago and Crestline, always operating on borrowed time. Every trip degraded rails and stressed switches. Dispatchers and shop crews built their schedules around its constraints, but the S1's limitations became impossible to manage. Other locomotives could be reassigned, rerouted, cycled through the network. The S1 had no alternatives. On May 5, 1946, it completed its final run. 3 years later, in 1949, the Pennsylvania Railroad quietly issued the order to dismantle it. No ceremony, no farewell. Just the slow, deliberate work of reducing a legend to scrap. The machine built to define the future had exhausted its options. Engineers in pressed uniforms stepped into the cab with genuine reverence, but that reverence didn't hold long. The S1 asked more than competence. It demanded a confidence the machine didn't always earn back. Crews talked quietly about the long, rigid wheelbase, the way it resisted curves, the constant threat of wheel slip the moment the throttle opened hard. Some called it the Queen Mary, majestic, but fundamentally mismatched to American rails. Others, less charitable, called it 140 feet of trouble. No regulation ever formally banned the S1. No official order came down from Pennsylvania Railroad leadership. No union bulletin blacklisted its number. But the result was identical. Crews traded shifts to get off it. Dispatchers quietly reworked rosters, assigning the S1 only when every other option was gone. The reputation moved faster than the locomotive ever did. Stories circulated about it hitting 140 miles per hour, numbers that lived in headlines and never in logbooks. The real record stopped just above 100.97 miles per hour. Everything beyond that was rumor, exaggeration, and the dark humor of men who preferred not to be aboard. In the end, it wasn't a mechanical breakdown that finished the S1. It was a human one. When the crews responsible for running a machine stop believing in it, its outcome is already decided. The S1 was never officially retired in disgrace. It was simply, quietly left where it stood. Innovation dazzles, Reality enforces the limits.
The S1 didn't fall short because of insufficient ambition. It fell short because the infrastructure around it refused to change.
Even today, breakthroughs only carry weight if they work within the systems that already exist. Progress isn't invention alone, it's adaptation.